Good morning, everyone.
Good morning.
Welcome to the Industry Advisory Council AI panel. We're really excited to have you all here. And we have with us a great panelist group. So I'll introduce myself first and then let them introduce themselves. And really looking forward to have this as a very interactive session. So we're not just here to talk about what industry is about and what AI. We need your input and we need your feedback to us as well. So my name is Naguib. I had a career in academy for 17 years and become a department chair of computer science at one of those universities. Joined IBM and worked through the careers. I became a chief technology officer and then I became a VP of IBM Global University Programs. So I was really looking, I possibly have contacted and interacted with most of your universities through my last 7 years. With us here is Matt.
Good morning, Matt Conwell. Thank you for having me on the panel. I work at a company called Invenergy. We're the largest global privately held renewable energy company. So we develop, build, own, and operate renewable utility scale. Thank you. Utility scale wind, solar, and storage plants, among other sustainable energy solutions. I've been working there for about 15 years. My role there, I run a multidisciplinary team of operations engineers, so we're responsible for performance and reliability of our utility scale projects, about 20 gigawatts for those who know their power. That includes a team of data scientists and data analysts who are responsible for analyzing all things data related from the equipment, as well as reliability engineers that span multidiscipline, mechanical, civil, electrical. But beyond that, I'm a member of the ABET's Industry Advisory Council. I've been on that group since 2021. I have a mechanical engineering background, Marquette University for those in the room, anyone, and Columbia University for grad school. And then we were going to talk about one fun AI anecdote, which I was going to mention. I had to upload a bio and headshot, which were woefully out of date, so I didn't have time to go to a photographer. Went to one of these AI apps, uploaded 5 selfies, and boom. So if you go to the ABET website and see my headshot, I credit AI.
Thank you. Andrew.
Hi everybody, I'm Andrew Lloyd. I am a civil PE here locally in Tampa. I went to the University of South Florida, got my undergraduate in structural engineering, but I do transportation. My background is in design. I'm a project manager here. I also have a master's in the MSCM engineering management program there as well. But so I am currently a project manager at AECOM. I know a lot of people don't even know who AECOM is, and I usually joke that's good because it means we're not in the news as an infrastructure company. So when I was at university, I did a lot of work with student organizations, some of them tied to ABET accreditation as well, like Tau Beta Pi. I also worked heavily with Beta Tau. I worked for the dean of the engineering college there as well, doing a lot of recruitment and talking to students and soft skills training, which I think is a major area that I appreciate their programs for, and we've kind of been making a lot of headway there. But I am excited to be here, and I'll share a quick little anecdote. I use AI probably the most for writing short stories for my son. He's 19 months old, and I'll get little bits and tidbits in there from our family history, and kind of I'm collecting a little bit of stuff for him as he gets older. He doesn't quite get it yet, but he will eventually. I think he'll enjoy it once he gets old enough to actually understand the stories. So
Wonderful. Thank you. Greg.
Hello, my name is Craig Kaplan. I'm the CEO of IQ Company, which is a consulting company that's exclusively focused these days on trying to develop safe artificial general intelligence. I've been working in the AI field since the 1980s, so almost 40 years now. And I'm kind of maybe on this panel because I've had a mix of academic and industry experience. So I started my career at Carnegie Mellon, where I worked with some of the actual founders of the entire field in 1956, the guys that named the field, Herb Simon, Alan Newell, Minsky, McCarthy. A lot of those guys got together at Dartmouth and named the field of AI, and I was fortunate enough to have a few of them as my mentors early on. But then I've also worked at IBM and been a serial entrepreneur in Silicon Valley, building intelligence systems. So my main focus, some of you may have seen the keynote. If you did, there was a very exciting video at the beginning, and one of the things that flashed there just for a couple of seconds was that statement from the Center for AI Safety that talked about AI represents, an existential threat on the par with pandemics and nuclear war and so forth. And what's interesting is it went really fast, but if you look at the signatories on there, it's not radical reactionaries. It's Sam Altman, the head of OpenAI. It's Bill Gates. It's Demis Hassabis, right, who's running Google DeepMind. So the top researchers in the field are concerned about the safety issue. It's a very small probability that something bad happens, but if it does, it's a very bad impact. And so I've sort of made it my mission these days, after selling my last company in 2020, to kind of go around and try to share my perspective on how we get to safe AI and safe advanced forms of AI, and also to learn from the audience, which I find is the most enjoyable thing. So hopefully we'll be able to say some things that are helpful in terms of what academia can do to train the next generation of AI researchers, but also how all of us can sort of work to make it safer. And I used up my time, so I'll skip the anecdote for now.
Wonderful, thank you. Matt, I know all of you work in the industry for years, and you've been having all the evolution of AI, and AI started coming to your industry. Can you tell us what does AI mean to your industry?
Sure, and I think it very much depends on who you ask and what their role is in an organization. And in my experience, in the last year, there's been a big focus, with the extreme explosion of popularity of LLMs among higher level individuals at the organization to do something in AI. They don't necessarily know what that means. So there's been a lot of education in terms of AI to a lot of people in the organization wanting to be in the space, not necessarily knowing how to be in the space. Conversely, if you ask an engineer, well, they've been using AI for years, and this is a tool in their toolbox, and they're like, what do you mean we have to start working with AI? We've been working with AI for years and years already. So it means different things to different people, but I think to everybody, it's an important tool that's going to be utilized in the future.
Wonderful, thank you. Andrew?
Yeah, I agree. I think it's significant who you ask that question to. Project manager might see it as a schedule tool where you can increase your productivity in a short amount of time, maybe a cost savings tool. If you ask someone in marketing, they'll have a totally different view on what AI means and what its use will be for them, what their use case will be. And I think it's one of those difficult things to define because it's such a moving target at the moment. But obviously we all have a general understanding of what it is, I think, and whether that's machine learning or generative AI or computer vision tools. We all have a general idea of what it is, but I guess we're all kind of constantly. I'd be afraid to give a definition because my definition might change tomorrow.
Thank you. Greg, I think with your history you just told us, you were working with one of the founders. You can tell us today what AI means to industry.
Sure. So, I think industry in general is pretty simple compared to some of the thought processes that happen in academia. Faster, cheaper, better is sort of the mantra. So if you have any new technology that can make something happen faster, reduce cycle time, or if you can improve the quality, or if you can sort of cut the cost. And AI is sort of, in a way, a holy grail, which is why there's so much excitement about it from industry, because it can do at least 2 out of the 3. It's really hard to get all 3. So maybe the quality is not quite where we'd like it to be. But certainly in terms of speed, we heard, I think, in the keynote again, the graphic that's on the screen there used to take weeks to develop. It was a matter of hours. I've seen AI systems do that in maybe not quite as good, but 30 seconds, right? It's really amazingly fast. A lot of what you would have a research assistant do, you can basically ask GPT or any of the large language models, and you'll get a lot of information generated in 15 seconds, And then we get to the need for critical thinking skills, which I'm sure we'll talk about, because it's not as good as a person in everything. So you still need that human to sort of serve as oversight. But I think industry is looking for those productivity advantages. And in financial services, which is where I worked for 14 years using AI, that was definitely the case, and we can talk more about that.
Super. Thank you very much. Back to you, Matt. Can you tell us how it's used in your industry and give us some examples, please?
Yeah, certainly. So I mentioned we have a few different engineering teams focused on our renewable energy projects. Some that are data scientists, and this is obviously a key tool that they utilize all the time. Other engineers that are also utilizing. But one of the ones that we've used for years and years are just AI to make a more accurate data prediction of like the power coming from an individual wind turbine or from a solar farm. Accuracy really matters. It matters when you're forecasting power prices, when you're trying to make your plan of the day and planning maintenance and downtime and things like that. That's kind of the most basic example. A little bit more advanced. In more recent years, we've been using machine learning models to have more predictive analytics. So trying to utilize a lot of different data signals from, wind turbine might have 300 different data signals coming from it. And to predict, say, the temperature of a component requires lots of inputs and a really deep machine learning model. And we've been very successful at increasing the forecast or the early warnings of some of the failure modes in the equipment. But the most recent that I'm very excited about is almost more of a deep learning model for wind turbine blade inspection. So the old process to look at a wind turbine blade was very manual. You had a technician with a telescopic lens taking photos of the blades, and they had to be trained to identify defects by eye. It's since moved to drone inspection. So a drone will now go to the wind turbine, do an autonomous flight pattern, collect hundreds of images, and then those images would have to come back to an engineer and then be reviewed one by one, which is very tedious and prone to error. So we built an AI model that would review the photos and try to identify and flag potential damage areas on the blade. And that cuts the engineering time to a tenth of what it used to be. That's been very successful, and that's really one that's kind of exciting. Shows a huge step change in what was being done before to what's being done today.
Wonderful, thank you. Andrew, we understand that AI is a cross-disciplinary field. It hits engineering, it hits humanities course, it hits medical, it hits pharma, everywhere. But from an engineering point of view, what kind of skills are you looking for from the graduate that's coming from university that at least you will be feeling comfortable that this person can work in AI?
So I'll start by just describing a little bit of civil engineering is very broad. I think that can be a difficult component of civil engineering and describing it to people. Our large infrastructure project, I kind of alluded to it earlier, AECOM is a very large company. We have 50,000 employees-ish, every continent. We're very large, so we have a lot of expertise in different areas. And one of our big selling points is that if we're hired, we can solve pretty much any problem you have. Knowing all those different disciplines, knowing all those different people, knowing who to go to, and having kind of the interpersonal soft skills to go and approach them, describe these issues, and be able to solve those problems with those people. I'm not an expert in anything, I feel like. That's why I'm a good project manager, because I'm not going to try to solve a problem on my own. I'm going to go to the expert, and I know who that expert is. I know how to describe the problem. AI is going to be kind of separating the distance between the highly technical and the people who have the soft skills, I think. I think that it is a tool that will, in some ways, level that playing field. I'm a little bit concerned that it may help decrease someone's value of that technical person, which isn't the right way to go, I don't think. That would be a negative thing, I think, for our industry. We're really concerned with the safety, health, and welfare of the public. That's one of ASCE's main credos for our ethics and the way we approach problems. And that's my biggest concern, is that students need to have a better understanding of that ethics and understand the social skills that AI will not completely make up for that. You need to be able to be client-facing. We have to not just communicate with our client, we have to communicate with the public, and we have to do so in a way that balances everyone's desires and interests. And that's not something that AI will be able to fix, but if students can rely on it, they're not going to be developing those skills, and that's one of the issues I'm concerned
Thank
with.
you very much. I think we have a question here from the audience. Start. Can I get the mic, please?
Thank you. It's just a thought, really. So, I mean, I've been thinking is, does AI and ancient Egypt have something in common? They actually do. For some ancient Egyptians, there was an ancient Egypt. So the status quo of AI, really, with all the generative AI that's happening and so on, is so disruptive, and guess what? We're disrupted. So when I look at how my colleagues are actually operating now in like software development and so on, there's so much pressure for people to start using the tools, but without much consideration for the engineering aspect of things, the economy of things, the technical debt that this accelerated usage just for the, to use the hype of the technology is creating for people in the future. The maintenance costs of those and the safety of the public is paramount. So at the end of the day, what I'm talking about is there are very mature AI technologies like detecting cracks and structures and things like this, which still have to be evaluated for correctness and so on. But then again, we have to be very careful about diving deep without having a population of people, graduates, who are ready to assess, who are ready to build those tools and improve on them and so on and so forth.
Sure.
Thank you very much. I see a hand over there.
Anytime, if I can respond to that one, I'll certainly agree. I don't think in the example I was giving about like our blade crack detection algorithm, it's not displacing our blade expertise team. In fact, that's grown even further. What this has been doing is really kind of supplementing what's become an exponential growth need in our industry. I didn't really mention this part, but our blade inspection needs have increased tenfold. And we found impossible to be able to keep up with that using our existing workforce. So it's really supplemental, not displacement in the case I was describing.
Wonderful, thank you. I have another question in the back here.
Yeah, just a quick, it's a connected question. So I think people are in a rush to train students because they see this, they're getting mixed signals, right? So if you're in a core engineering discipline, so civil engineering, mechanical engineering, so there's a group of people in software, computer engineering who are developing these tools, so I can understand them getting trained and developing these models, etc. But for those in the other disciplinary areas, what, at this point in time, is there a change in what the expectations are for those graduates? Do they need to understand prompt engineering? Are you expecting them to use this in an effective way, or talk to other people who are going to come to them and say, hey, this is what the AI model told me, does this make sense? So could you give us some sense, because I'm from an academic institution as well, and like many academic institutions, the senior leadership is saying, oh, we got to develop an AI model, we got to do this, we got to do that. And so people are rushing to do stuff, and our advisory councils are saying, yes, we would like students to be aware of this, but really that's the broadest statement on earth. So, so any guidance you can give would be helpful. Thank you.
Yeah,
Thank
I think that's a very valid interest and concern and area we need to focus on. I'm immediately thinking of the term data governance, which I know is a pretty broad concept. It deals with validation of data going into a model, knowing that that data is not, if it's privileged information or information that should be protected. I mean, we look at bridge plans, and those are things that you can't just access unless they know who you are and you've signed off, and that data is controlled. And knowing that the data that's coming out is being validated, those are all really critical components. And I think that currently students coming out of university are going to have, some are more confident than others. And I think part of that is going to be getting them, I think it was mentioned in one of the other panels to discuss, or one of the other presentations, that giving presentations would be a good way to help students learn to communicate that information and demonstrate their confidence in their ability, because they have to know and be comfortable saying that's wrong. A lot of times we get information and we just accept it and we don't question it because we are getting it from experts. But now we're getting it from someone that is not an expert, that may be hallucinating information, which is the term used for the made up stuff that sometimes comes out. And you have to be confident enough in yourself to be able to question that information. And I think that that's something that is developed over time by students as they become professionals. and as they become a little bit more knowledgeable about the different areas of their problem they're solving.
Craig, do you have a point?
Sure, I'll add to that. I want to echo, I guess, what Andrew was just saying about, in my mind, I think of that as critical thinking. Critical thinking is not going out of style anytime soon. In fact, if anything, it's going to become more and more important. The ability to discriminate, this information seems accurate, makes common sense, resonates with my expertise in the field. This other information sounds great, but it's completely made up. And sort of quick anecdote on that point. At a previous conference for fun, this was right after, I guess it was in November, OpenAI just released their latest version of GPT-4 and big fanfare, turbocharged and everything. So I said, okay, great. I'm going to have it write my speaker bio. And I said, make it sound great, marketing, but only say things that are truthful. It's really important that it's truthful. And it sounded fantastic, but it had me, graduating from Stanford, running some company which turned out to be a Russian company. The website, it went off the rails, but it sounded great. And if somebody didn't know my background, they'd say, wow, okay, this all sounds believable. So that ability to discriminate information is very important. I'll just say one other quick thing. In terms of skill sets that are needed for training the next generation of, I would say there's AI users and there's AI system developers, two different groups, and then maybe some people that are kind of in between. So for the user group, I think some basic knowledge of how these systems work. You don't have to become a machine learning expert, but just a basic understanding that these are essentially current LLMs anyway, large language models, are predictive machines. You're loading in a lot of data and they're just analyzing all that data and they're looking for patterns and they're predicting responses. It doesn't mean that they necessarily understand the subject matter in the same way that a human would. So understanding that, understanding the importance of the data, garbage in, garbage out, it was in the keynote, can't emphasize that enough. That's really important. For the folks that are developing the systems, there I think expertise in, of course, all the different algorithms, which are constantly changing, is helpful. But the one thing, and you'll hear it probably at this conference, but also if you went to other AI conferences, it's like the theme, which is data, data, data. Everything is data-driven now because of the way these systems work. The systems are basically gaining their intelligence by analyzing huge amounts of data. So when I was running the financial services company for 14 years, our biggest challenge and the thing that we looked for when we were hiring folks was expertise in data science and experience managing large data sets. You would think naively, or at least I thought naively, financial data that comes from the stock exchange, for example, should be relatively clean. I mean, after all these funds are, paying, millions of dollars for it. No, I mean, it took months to kind of organize that data, clean that data, put it in a form where you could have your machine learning algorithms sort of really use it effectively. And it's the same across any field. If you're in medicine, getting all the data in the database, medical database about x-rays or whatever the field that you're trying to do. So some skills with data, I think, cut across pretty much every field, engineering, science, and even if you're not, a developer of the most leading edge AI system, but you just want to sort of tune one that's out there, you're going to need some data science skills. So that's something that has become very, very important.
Wonderful. Thank you very much. We have a question over here.
Thank you so much. Yes, Greg and Andrew, you responded amazingly. And I wanted to ask you some questions, but you already responded some of Tatiana course. So, when you said this mantra in industry, quickly, cheaper, and faster, and I would add one component, made by whom? Amazing people retire, they have this characteristic, okay? So we have new workforce coming up, Gen Z. People who born after 2000, and they radically different from previous generations, and it's a lot of research already been done about it. First of all, impulse control. Second of all, these kids born with gadgets, nerve system, reaction on stress, ability to think, and I'm very interesting you said that critical thinking and soft skills still very important. The AI won't replace it. So these new kids on the work on job market, they very different compared to previous generations. And what companies, what industry can do to train them maybe, because they are not ready to go. They're not. We see them in academia every day. They are not. And many of them have this misconception that AI will take our places or they will solve our problems. And you are expecting from them already ready to go, you know, be ready to solve a problem. And I think it is disconnect between what industry expect and what academia can offer. Specifically for this new upcoming generation. Plus, we adding to this AI stress, you know. Yeah, and also, you know, it's a lot of research basically showing proof that ADHD, autistic, disability kids, basically the, students increase on campuses, mental health issues. Now they all in job markets, you know, and many of them want to be engineers. So, you know,
So
your comments.
This is hit my last 6 years of my job at IBM. And we found exactly the main point that you talked about. We had about, I don't have 4 years runway to get a graduate, and in the meantime, I need someone tomorrow. So the companies start, which is not micro-credential. You have to differentiate between the street micro-credentials for money and the company training models for a graduate. So what we created is a real set of training modules for the graduates we need. And we do it in twofold. The one that is coming, I give them 3 months of training and I focus on what I need them for. And the one that I build a collaboration with universities, that's where I mentioned at the beginning, I collaborated with most of all universities globally. So what we did is we went to university and said, okay, let's build together a program. And the 4 areas, just to be, all of you are engineers, and you know the 4 areas that impacting the life of every person daily are already exist. There are cloud, security, data science, and AI. Coming the 5th is quantum, but it's not here yet. If you want to talk AI, you have to understand security, you have to understand cloud, you have to have data science. If you give me one that just to talk modeling, they cannot load it to the cloud. If you give me someone loaded to the cloud, they don't know how to secure it. So all of these 4 together are one category that we train the people coming. So while I'm talking, I actually jump in here because this is what I did with universities for 6 years. What we ask universities to do and look at is get the graduate well-rounded around the core of AI. Call it AI evolution. So don't give me someone do a modeling. Now I have to look for someone to load it. Now I have to load someone how to secure it. Now I have to look someone how to analyze it. Make that graduate, I'm not asking them to be professional, but aware of, and then when you put them next to someone expert, they can interact. You don't want the seasonal person to say to the Gen Z, stay away. No, you want them to bring them with them, right? So those twofold is train when you enter the job, and also work with academia, and I can tell you many universities are now working with industries, regional and globally. I did it to IBM, I know Microsoft is doing it, I can name all companies. All companies realize that this is the need and this is what we can do quickly to get our technical resources. So please, if you have any companies around you, reach out to them and work with them in that field.
I'd like to just add some thoughts on that. One of the things that I always did, I know Tau Pi had their Engineering Futures program. I don't know if anyone's familiar with that, but it's a soft skills program. We would go around and we would give presentations and workshops with students. Those were very valuable, and I always kind of noticed the difference between myself and the students that I was working with, and it's something I've kind of grown up with. My parents were always older. My parents were the age of most of the people my age as grandparents, just the way it worked out. I was the second marriage child. So I always behaved a little bit more like everyone else's adults, their parents. It was odd. But as I've aged, I've seen more of what you're saying. People are coming, they're growing up, their personalities are different, they have different interests and priorities. And so mentorship is really big. And I think encouraging them to take on leadership opportunities and experiencing the soft skills and the benefits of having strong soft skills is really important and critical. I think motivating students to do that and incorporating soft skills training into everything that's happening is one of the best ways to prepare them to be able to interact with not just their local little cohort.
Yeah, I'd maybe add just like, I think some of your concern gets to the broader mission of ABET. We were meeting yesterday as part of the Industry Advisory Council and talking about the value of ABET accreditation. And part of that was getting candidates that we think are more prepared for the workforce, that could hit the ground running more, that have curriculum requirements that include some of the soft skill training. I don't know that that addresses like the generational gap that you're talking about. That might be a bigger issue, but certainly I think that's an area where ABET as a whole helps.
Quick comment. So I agree with everything my fellow panelists just said. So I'll skip that part. But it was interesting. I was chatting with a graduate student at this conference, and kind of saying some of the same things that were in your question, like, gosh, we got to worry about this, worry about that, and there's all these things, and it's changing so quickly. And the student said, it's interesting that you have that perspective, but to paraphrase, they were basically saying that, look, it's just, we grew up with this. This is what we're used to, this AI. It's not something scary or new for us. And it made me realize it was sort of a reset. That yes, there are challenges where mentoring is needed and classes are needed and certifications are needed to sort of bring them to a certain level to fit in the workplace. But also something that that generation brings is a familiarity and a complete and utter lack of fear of this technology, which is really encouraging and probably something that we need going forward. So I just wanted to emphasize that as well.
We have a question over here.
Yeah, I have a question to Andrew, right, in the middle. Yep. So Andrew, don't take this question personally. So it's just a question from an educator to a practitioner. So take it like that, because I'm somewhere in between an educator and a practitioner. So I like the sentences where we say, okay, we're using AI in healthcare, we're using AI in project management, we're using AI in scheduling. So you mentioned a couple instances that you're using this in scheduling and also use cases. So if I want to teach my students scheduling, right, a critical path, all of us understand, and all the terminologies you used, we all understand, and we're teaching them. But how exactly you mean we're using it in scheduling? And is there a software that you're using that we don't have access to because it's a proprietary tool? Is there like a data that you're using that we don't have access anyway? What am I to teach my students, right? So we're going to send you the next generation project managers and construction managers, but the soft skills that you talked about, it's great because all of us here are covering presentations and all of that. In fact, a very big role for a data scientist is storytelling. If your accuracy, like Matt mentioned, it's great. We have great accuracy, but we don't have the soft skills. Well, the next step is you have to present. You have to write a report and all of that. So yeah.
Right. Yeah. So I'll clarify. We are not using it for scheduling right now. This is more of a theoretical, broad stroke type of a comment that I think with people in project management, they see it as an opportunity to look for ways to do things faster, is more what I meant. More than actually adjusting it for scheduling and like construction management type of stuff. And cost savings to make just certain tasks more efficient and faster. Hopefully that answers, yeah. So I think you're doing fine probably with your current scheduling approach.
if I could add.
Send him an email and get the tool.
The truth is, AI and the tools around it are moving so quickly that whatever you would teach today is probably going to be outdated a year from now. So what you teach isn't what the tool is. It's to instill that you're going to have to stay up on this. This is something that's constantly evolving. Be on the lookout, not to be afraid, like Craig was saying, like don't be afraid of the technology, which it doesn't sound like they are anyway, but be on the lookout for what's next and be ready to adapt quickly.
So I'm going to put on my volunteer hat as a PEV, and the question that I would ask is how do the programs demonstrate that they assess and evaluate critical thinking? Let me rephrase that. To the panel, what do you believe would be a good way of assessing and evaluating critical thinking?
I'll throw out my thoughts on that. I think a lot of times we focus on right or wrong answers, right? I mean, everyone's used to taking math classes. I remember when I took my last math exam and I was super excited. I didn't have to worry about partial credit anymore and whether I was getting the answers right. I think asking open-ended questions and having students approach things from a more broad approach might be critical, that they can present on why that is their solution. And I think judging them based on how they solved the problem versus if they solved it a specific way, I think is critical. I think that happens further along in their programs. Earlier on, they are learning basic concepts and it's hard to do. But I think that might be one approach, is just give them more broad opportunities to have a longer form thesis, essentially, for their class. That way they can present on something and give a more thorough, thought-out explanation, have that critiqued by their peers, be willing to debate those things as well.
Got it.
Thank you. We have a question here.
Okay.
1, 2, and 3. Okay, yeah, this is for Craig specifically at the microphone here, I see. So when you sat around, you worked with some of the great founders in the field, but talked about artificial intelligence and coined the word. Is this the AI that you all envisioned at that time? It seems to me there was, back in those days, there was an element of artificial intelligence, meaning intelligence, meaning artificial consciousness, or some type of, we had enough complexity or enough data or fast enough processing, the computer would become self-aware as opposed to just predicting what the next word we're wanting to hear is. So I don't know, what's your thought on where we've ended up with AI versus what the vision was back at CMU and et cetera?
Okay, that's great. I love that question because I get to just ramble, and I'll try. Naguib will give me the hook if I go too long. So it might be useful. So this is one of the things that is helpful for me, is to sort of step back and look at a trajectory. As Matt was saying, everything is changing so fast right now. You go to one AI conference and another one a month later, and there's new research that nobody's heard of that is not just sort of an incremental improvement, but like radically different, right? So, I mean, I've never seen a field moving so quickly as what's happening right now. And that can kind of make your head spin. So sometimes it's helpful, to your question, to step back and say, well, what's the long-term trajectory? So I'm going to give you, as concisely as I can, my view of that. So I break AI into sort of 3 periods. We'll go past, present, future, all right? So past, we'll say 1956, when the field was named, to 1986. And that was the era of symbolic AI. And symbolic AI, some of you may be familiar with the term expert systems. So that was an era in which AI was envisioned as an expert, and the way that you made it an expert was you found a human expert, and you then did knowledge engineering. You tried to extract what they know and put it into rules, like if-then rules. If you were building a medical diagnosis system to diagnose pulmonary disease, if this symptom, then that sort of thing. And then it was all programmed in. And there were pluses and minuses of this approach. So one of the benefits was you actually understood how the AI worked. And if it gave you, it didn't really hallucinate, but if it made a mistake, you could go find the rule that was wrong and you could fix it. And that was fantastic, which is not the case with large language models right now. But the problem with it, and at that time you had folks saying, I mean, my old mentor, Herb Simon, was famously saying, we were going to reach that stage that you alluded to in your question. It was always like 50 years out. So from 1956, it would be by 2006 we'd be there, right? And then it always proved a little harder than you thought. Kind of like Elon Musk with self-driving cars. It's always going to be full self-driving completely is just around the corner. Those problems are very, very difficult because people underestimate the amount of complexity in the world and the amount of knowledge that humans have. So kind of the downfall of symbolic AI, or the challenge of it, was you simply couldn't get enough information in fast enough to be able to reach sort of that nirvana state of this AI that has general intelligence. Okay, around 1986, what happened, and it was wonderful, because I was, by pure luck, like Forrest Gump, I was in the right place at the right time. Right when the symbolic era was sort of peaking, there was this new movement for machine learning, which is now the dominant form of AI. And what happened was folks said, well, wait a minute, why should we program all these rules into AI to get them to behave intelligently? Wouldn't it be great if we could just have the machine learn it all on its own? And that actually was a tremendously excellent idea. But the problem in 1986 was computers were not fast enough. And so we basically had to wait 30 years of Moore's law, doubling processing power, until you could get, cars that can drive reasonably well using AI. We had it in 1986. I remember in Shenley Park across from CMU, they had a van. It would drive. It was self-driving, but it went about 1 foot every hour because it was loaded with 286 computers, and it just was really, really slow. So if you want to go 60 miles an hour, you got to wait for Moore's law to catch up. Okay, and so the idea of machine learning was a good idea. You needed the computational power. We now have the computational power. Unfortunately, it comes with a drawback. When you have a model, a very sophisticated model that has 750 billion parameters, right? Free parameters. When I was a scientist, I was taught to minimize the number of free parameters in your theory, right? I mean, that's a good theory. It explains lots of data with very little free parameters. AI systems, completely the opposite, 750 billion things. It's impossible for you to know which of those parameters are leading to the behavior. So you now have all these NVIDIA GPUs and very sophisticated computational power. You have machine learning algorithms which are somewhat improved from what was there in 1986, but to be honest, not that much. I mean, somewhat. What's really happened is those GPUs and the computing power. So now you can just shovel literally 3 Library of Congress's worth of data, which is about what those GPT-3 was trained on, of data at it, and say, find the patterns in this data, and then when I put in a phrase, predict what the phrase that you should say out is. And you have no idea what that representation is. You don't know what the internal rules are, so it's a completely different approach. Okay, so that's where we are now. Now I'm going to give you my view on the future, which I think is controversially leading towards the original hopes. We're going to get there eventually. And I think what's necessary is a combination of the 2 schools of thought. The symbolic AI, which is really needed for reasoning and planning and sequential thought, and the massively parallel, shovel lots of data, look for patterns. We don't necessarily need to know how you're detecting that this is a rabbit and that that's a giraffe, but if you can do it with high accuracy, we'll accept that, and then we'll combine the symbolic reasoning on top of this pattern, massively parallel pattern recognition. Interestingly, if you look at sort of what's been happening in the last year in AI research, it's a rediscovery of that symbolic AI. They're citing the old papers. It warmed my heart. I was like, wow, finally, I've been waiting, because those guys had figured it out in 1972, and now it's like, oh yes, we can, and it's as if, oh, this is a new thing. It's like, well, yeah, it's kind of new, but actually some of that the original founders had thought of. So I think it sort of goes in fits and starts, and I think we eventually will get to that view where you have intelligent agents and intelligent entities that are on par or even beyond humans. And the key, in my view, is all of us as engineers and scientists and researchers, we have a limited window in which to design the system that will become that, such that it is safe for humans and ethical and does the right things. And we need to act now, and that's kind of sort of really the message that I'm trying to get out.
In other words, you're saying we should make sure we don't read Skynet from Terminator.
Right, until it has human values, yes.
I'm trying to give 3 people a chance to be raising their hands pretty quickly, so
take it away from
we have about 15 minutes left. So 1, 2, and 3, and 4 jumping up. Okay, go ahead.
Thank you so much. I feel like everybody in this room got a crash course of the AI history. I teach AI literacy, and that's like the first day. It's the timeline, including AI Winter, ELIZA, IBM Watson, etc. So I'm grateful. We've had level setting happen here. My question is, yes, a lot of these thoughts have been done before, but something that's new and more existential is the word sustainability. And you mentioned power consumption, and when it comes to industry, right now, like in academia, access to models, like $20 is pretty expensive. There's Hugging Face, but they're not as good. Is industry open to financially supporting in democratization of AI with education? How does that model look like? Have you thought of it? And the second part is, where does sustainability come in? Because sustainability is often pitted against development and pioneering. In your day-to-day jobs, what does sustainability look like at like a grassroots? I'm not talking about companies, because all companies have sustainability boards with goals and values, but they don't really trickle down. And our students are going to be working. What can I tell my students about sustainability that will be relevant, along with the data part? And this is
Take
for
a
all
crack
panelists.
if you want. You want to? Okay, I'll do a quick crack and then I'll give my other panelists a chance. So on sustainability, I mean, there are companies out there, NVIDIA is the one that comes to mind, right, that makes a big deal about high performance computing and getting much more computing power with more energy efficiency. And that's really a design problem. So there are engineers that are working on this, trying to, because it's a real problem, as you say. I mean, if large language models and other forms of AI are increasing in their computational needs by a factor of 10 every 6 months or something like that, and you just plot out what the energy consumption is, pretty soon it's using half or more of all the energy produced in the world. So it really does need to be addressed, and there is some work that's done on that. On the ethics side, well, there's a lot to say there, but I think developing agents and having ethical knowledge as well as practical problem-solving knowledge and domain-specific knowledge being trained at the same time and in a democratic way, I think is my personal view of the way to go. So currently, I'm a little concerned that, I mean, Silicon Valley is sort of carrying way too much weight on this right now. And you have a relatively small set of engineers that are putting their values and ethics, and they're well-intentioned people, I think, you know, at least the ones that I know. But nevertheless, it's a small sample and coming from a very narrow culture and a very narrow geography. And I just think that that's probably not the best path forward. I think it needs to be much more representative and democratic. Why would a large company support this? I mean, I can imagine companies, I'd be surprised if Meta doesn't have this in their plan. I mean, they're already doing a lot with open source models, Llama, and if you think of it from a business point of view, which is where my brain goes these days, I mean, everybody has an Instagram profile or a Facebook page or whatever. There's all this personal data. How easy would it be to press a button and customize your AI using your social media profile? And if it could, hopefully, in an ideal world, also have some of your values at the same time, you could get a lot of people's ethical values and feelings about what's right and wrong in lots of different customized AIs, which then could come together. So it's a much longer conversation, but there's things that are going on, and I appreciate the question. And maybe you guys have some comments.
Add that because we have a question and two here. Go ahead.
Well, I was going to say I don't have an answer for that. That's a very complicated question.
I mean, I was going to say from an energy standpoint, that's kind of good for business for me as a power producer. It's encouraging to see companies, you know, taking that into their goals. Though we work with obviously a lot of tech companies in terms of power purchase agreements, and we've even seen some interesting cases with, especially in like crypto field, where obviously that's like a big power drawing that has a lot of concern around it, about being positioned in areas where you get a lot of excess power. There's a lot of areas in the country where, you know, like especially in like West Texas, where at certain hours of the day the power price actually goes negative because there's so much excess power, wind power being put onto the grid that there's not enough demand to meet it. So putting you know, remotely located facilities that can utilize that power has become really popular.
Wonderful. Your question, sir. I know you're being patient.
No. Thank you. So you answered this question like today, but I want to just put it in a context and ask a direct question about this. So considering all the new generative AI tools emerging every day, like hundreds of them every week, so imagine, let's say you need to hire a new employee today as engineer, and then you have an interview today. What would you ask differently? So than last year, and then what kind of an answer would impress you?
So maybe I can start with that one. Especially like if you're talking about a non-specialist in AI, like you're talking about like a mechanical engineer, or civil engineer, electrical engineer, that type of As we kind of were talking about before, I don't expect them to be an expert and like a developer, a model developer. I expect them to have a good deal of literacy around the topic. Some project experience would be impressive if they worked in a multidisciplinary project that utilized AI within their group. That would be an impressive part. Because the fact is, in their career, even if they're not developing models, they're going to be working with data scientists, and they're going to be interfacing with AI tools in their careers. If not that, then at least having some degree of literacy around, what is the difference between, say, a deep learning model and a machine learning model? Understanding that a deep learning model, Craig was saying, isn't going to tell you anything about how it got to that solution, whereas like a machine learning model maybe kind of weights different variables and will give you some insights into what's happening in the analysis. That's the type of thing I would expect from a graduate coming in today.
Yeah, I would just add, I always look for practical applications of new technology. If there's something that I've heard about in the news or something, I will ask their opinion. AI is the big buzzword right now, so I know I'm using it to expand my own skill set. So I'd be interested in, have they done anything outside of their discipline or used it to do something creative that they normally wouldn't have been able to? How have they supplemented their capabilities with it?
Bedtime stories.
Yeah. I have an answer to that, which is not necessarily specific to AI, but this is really what I look for when I interview folks. Kind of like in science, we're taught that we're supposed to look for evidence to disconfirm our hypothesis, right? That's what a scientist is supposed to do. You have a theory, you're supposed to find a way to disconfirm it. You poke as many holes at it. I find that most people don't do that. Most people want to look for things that make them feel like they're right. And so when I have an employee, of course I'm looking for a smart person and someone who understands some data science and so forth, but I really am also looking for somebody who's willing to seek the opposite of what they think, or to see the other side of things. To me, that's what really makes a valuable employee. And also, my nightmare employee, to put the flip side on it, is the one who's really smart and very confident and sort of designs a system or something, which I've had, and says, this is going to work for sure. I back tested it. It's great. It's all that. And just 100% confident this is it. And then the thing crashes and burns. A little bit of humility and self-questioning, it goes a long way in a lot of situations.
Okay.
Thank you. So I had some similar thoughts about green AI and so on, but that's been answered. But Naguib, you mentioned something that caught my attention. You said quantum, but it's not really there yet. See, but I guess the industry probably needs to be far looking ahead, because the paradigm of quantum computing is going through the same, in my opinion, evolutionary stages like computing was maybe 40, 50 years ago. And again, it's a very different paradigm. The abstractions and the tools aren't there. But can you tell us more about why you've mentioned that?
Okay, the quantum, we'll go back to where AI was, is going to be a different structure of hardware which is not yet produced. So companies are doing twofold. Producing the hardware that really can do efficient work with the least energy, because it goes very hot quickly and all that. And then also the developer that would write the programs and the processing and all that goes into the quantum. Those skills, I can tell you, started from zero maybe a few years ago. So we don't have yet in the field and globally enough talent of these two pools that quick development as well as quick software. So that's where it is slowly coming gradually. I don't want to say it maybe within 5 years you will find the marriage between the struggle that AI is having and the computational power that will come from quantum coming together, and in that case you will have the second evolution of AI into quantum. But I don't want to say what's today using and today developing and today work in many fields is AI already. So AI hits very quickly, very fast, and that's why you can see it's using standard classical computing, is using GPUs around. The long, I don't have I'm sure you know, not just IBM working in quantum, Microsoft is also working in quantum. 2 years or 3 years ago, Microsoft said, we made it, we mastered it. And then some people say, I don't think so. And then they kept quiet, right? So the rush for quantum was very quick, but the reality of quantum is different than the reality of AI because you really have to manufacture and do the hardware first correctly. So that's where I said it's going to take a few years. Okay?
Yeah, just comment more kind of close to ABET needs as a PEV as well. When you go to higheredjobs.com, it's a whole bunch of now flourishing positions for faculty teaching AI, all right? So when we do an accreditation for any program, ABET, for example, you have to specific kind of satisfy certain requirements. One of them, faculty prep, and my kind of concern and question, how to prepare faculty who can teach it now, How to find personnel who knows how to dig in, teach, and then program can be evaluated, because this fall you go to campus, to make accreditation and UPEV, how to specify this checkpoint, faculty prepared, credentials of faculty.
Correct. Let me hit that too. Companies, including what I was doing, we go to universities and we, not just to students, but we also ask the university to give us the faculty, 1, 2, 10, it doesn't matter, where we train them to, because you can't train the students where their faculty don't know what they know. Right. So it was actually a two-stage. First, the university select the faculty that interested to learn. The faculty learn it very quickly in a short time. The faculty then work with the industry together in the classroom to teach the students. By few trial, I call it, attempts, the faculty now can catch it and go to its own. We realize that. I'm telling you, I travel the world and I've seen countries, they don't have a PhD in AI. A country, not a university, a country. I have seen universities where they're struggling to get some master's or PhD in AI over in Europe. Once the person is finished an AI PhD, the person say goodbye, I'm not coming. Why? A lot of euros over there. Right? So that's a struggle the world is facing. So the only, I can call it, I always say it is a triangle collaboration. The industry, the government of the country, academia within that industry. You don't get one and leave the other two. The three together need to put their head, put a strategy. What is the AI strategy for the country? What is the AI strategy for the state? What is the AI strategy for the university? And then you get those three entities in the room and put a plan and a strategy. One by itself will not survive. I think we're almost there. We're getting the flag for 1 minute, 2 minutes.
I know I have to be,
okay, sorry, I didn't see you.
I know I have to be really quick because this between me and lunch. So, really, Yash already asked my question about sustainability. Thank you for responding to that and understanding that it's an amazingly huge issue. My other comment is really a friendly suggestion. In the engineering education world, we're moving away from using the term soft skills because it's perceived as being less important than hard or technical skills. So I would suggest using the term professional or leadership skills, which tends to be much more, the perception is more important.
More perception.
Yeah, exactly. Thank you.
Thank you very much.
I like that. Professionalism, was that the term? Professionalism skills?
We do call it professional development, I guess.
Professional development skills? And leadership.
Professional and leadership skills. We come to the closure, and I would really want to thank you very, very much for your questions and your attention and all that. And I would like to thank the panelists and all of them. Please, this is a great panel on the